The ICEVI, the Nippon Foundation Mathematics Package for Teachers video series, Abacus as a Mathematical Tool. Title of the video, Square Root of an Imperfect Square. Example, 46,369. Let us consider this number 46,369 and set that in the abacus by leaving 3 columns to its right. That is 9 in the thousands column and 6 to the left of it and 3 to the left of 6 and 6 to the left of 3 and finally 4 to the left of 6. Take the first group 463 and consider the highest perfect square there, which is 441. Take the square root of 441, which is 21. Set 21 by skipping a column to the left of 4. Now 21 multiplied by 21 equals 441 should be subtracted from 463. That is 4 subtracted from 4, 4 subtracted from 6, which gives 2, and 1 subtracted from 3, which gives 2, and therefore the remainder value is 22. The number left in the problem at this stage is 2,269. In the next stage, double the square root part and set 42 in the extreme left of the abacus. Consider 4 the highest digit of the number on the left and 22 the highest 2 digits of the remainder. Ask how many 4s in 22. You get the answer as 5. We can go for an assumed quotient too by considering 4 to begin with. However, we can consider 5 also in this case. We can always reset the number in case the assumed quotient is larger than the actual quotient. For the time being, set the number 5 to the right of the first 2 digits of the square root, 21, and to the right of the number 42, which is set in the extreme left of the abacus. Multiply 5 with 425 and the value should be subtracted from 2,269. That is 5 multiplied with 4, which is 20, and this is subtracted from 22, leaving the remainder as 269. In the next stage, we have to multiply 5 with 2, which is 10, and the remainder after reducing this from the 269 will give us 169. Let us multiply 5 with 5, which gives 25. That should be subtracted from 169, and the remainder we get is 144. Therefore, the number 46,369 is not a perfect square. Now you have to go for your decimal part of the square root. Add 10 to the number 144 and it becomes 1440. From here on, you can simply follow the regular division procedures in getting the decimal part of the square root. For getting the divisor, you can double the square root 215, which is 430. That can be set in the left extreme. Now, there are 3 times of 430 in 1440, and therefore you can set 3 to the right of the square root and multiply 3 with 430, that is 1290, and that should be subtracted from the 1440, and you get the remainder as 150. Therefore, your first decimal digit of the square root is 3. Now you add one more 0 to the dividend 150 and you get 1500. There are 3 times of 430 in 1500, and therefore set 3 as the second decimal digit of the square root already set in the abacus. Now 3 should be multiplied with 430, that is 1290, that should be subtracted from the 1500, that gives us the remainder 210, and your second decimal digit of the square root will be 3. So therefore the square root restricted to 2 decimal points is 215.33. If you want the third decimal digit of the square root, you can add one more 0 to the remainder 210 and then go ahead with the calculation.